Okay. Yeah. So this can we start the
sharing our screen?
Yeah.
So hello, my name is Cha, and here are my partners. Her name are Vũ Bảo An and Nguyễn Minh Trang, and together we are here today to introduce our project about fabrication and characterization of Fe2O3 nanoparticles. Just wait a moment, we are trying to figure out a way to share our screen. $1.5 million is the number of people dying every year due to antimicrobial resistance. Moreover, in today's COVID-19 pandemic, the urge for medical treatment is the #1 priority. Acknowledging the emergency of this phenomenon, we, ordinary teenagers from Hạ Long High School for the Gifted Students in Vietnam, wanted to contribute in tackling this issue. So together, we're here to introduce our project about the fabrication and characterization of Fe2O3 nanoparticle for drug delivery application. Our presentation will be divided into 4 parts, namely the introduction, experiments, results and discussion, as well as the conclusion.
So as we all know, drugs can be provided orally in form of liquids, tablets and capsules. People think that's the safest way to do, but it actually can harm our digestive system. And therefore, however, the digestive wall and liver can chemically alter many types of medicines as they pass through. Besides, food and other chemicals can also affect the absorption of the drug. The second common type of drug delivery is by injection. Physically, when we take a dose, the drug molecules will be transported throughout our bodies, and therefore, the tremendous amount of drugs have been used for the wrong purpose, and consequently, there's a likelihood that it might create such serious side effects, so that can risk one's health.
Nanoparticle delivery systems are engineered technology that use nanoparticle for targeted delivery or controlled release of therapeutic agents. The modern form of drug delivery system should minimize the side effect as well as the dosage and dosage frequency. So in our project, we will synthesize Fe2O3 nanoparticle for drug delivery application.
So moving to the experimental part, so the ferric oxide nanoparticles were synthesized by slowly adding 100 milliliters of FeNO33 solution to 500 milliliters KOH solution with a rate of 2 milliliters per minute. Then a colloid containing FeOH3 particles was then generated by stirring the fluid for more than 10 minutes. And after all, the mixture was centrifuged at the rate of 3,000 rounds per minute, and after that we dry the mixture in the air at 120 Celsius degree and heat for 400 for the next 2 hours. So moving to the result and extraction part, the diagram you are seeing here illustrates the conduction of the ferric oxide particles. You can see there are 8 diffraction peaks, and all in the peaks coincide with the peaks of the structure of the Fe2O3. So the peak has a sharp shape and low diffraction, so this means the material has a really crystallinity. And also these XRD results show our success in creating the ferric oxide material. And most of the obtained nanoparticles are spherical and cubic shaped with an average size of 10 nanometers.
So in figure 3, this is the dispersivity of ferric oxide in water and hexane. So after 2 weeks dispersing them in water, which is a polar solvent, we can see that an insignificant amount of agglomeration and precipitation of the nanoparticles was observed. Meanwhile, in hexane, a non-polar solvent, these materials transferred quickly into water phase after shaping about 1 minute. As we have mentioned, the ferric oxide nanoparticles can be dispersed in water, and they can be transported easily throughout our bodies, hence be able to reach the injuries faster without being blocked by the digestive system.
And the field-dependent magnetic measurement of the sample was carried out by vibrating the sample magnetometer. And it appears that the ferric oxide is a superparamagnetic material, as the magnetization shows that it has approximately 60 EMU per gram.
Richard Feynman once said, "There's plenty of room at the bottom." Indeed, it is undeniable that the nanos world is thriving in today's era, with different purposes, including in medical treatment. In our study, we have successfully created nanoparticle with magnetic and water dispersible ferric oxide for drug delivery. In the future, we hope to find the most effective medicine to combine with this material, as well as to do more research on other material can be used for medical purposes. We believe the well dispersion in water and the magnetic of ferric oxide nanoparticle could possibly open up several potential applications in medicine. This is all of our project. Thanks for your attention.
Thank you. Thank you for your time. So basically, we really love you guys how you found the side effects and having an experiment. So you guys find the side effects by different drugs that were wrong purpose and wrong use that cannot digest in the human body. That's why we guys experiment to get a precipitation rate to how to deliver drug and apply in our body and digest in our body. So you guys found the spherical cubic nanoparticles, right?
Yes.
Yeah, so that was so brilliant. But what we want to ask about is, can these or can your study could use in the real life? Like, you can, I want to know that, how this study could be used in our real life, like in the medical area.
Well, to the best of our knowledge, we have do some research that there are actually many researchers have found a way to put the theory of nano-based drug delivery into practice, such as the University of Houston. They have found the antibacterial way to using Coben Fe2O4 to deliver the antibacterial to the place that had been harmed, or another university that they have found a way to test the cancer ability in our bloodstream using this technology of nano.
So it can easily dissolve in human's body and with the water. So it doesn't have any side effects. And it has a proof that it was used in university like dentists or other experiments, right?
Yes.
Okay, then that's clear. Because when we first started off you guys' presentation, we realized that this cannot be applied to human bodies. But since you guys say this can be dissolved in water and with the mixtures of nanoparticles, so it has a reality chance to make that your experiment is provable.
Yes.
Yes, of course.
Yeah, yeah, awesome. Thank you.
Thank you.
So, yeah, with the 6 minutes presentation and 3 minutes question time, Q&A time. So thank you for your participation. Thank you.
Thank
Yes,
you.
thank you.
Bye, anh Nhân.
Thank you for being there.